question is from the chemical equilibrium relating to the decomposition of PCl5 to give rise to PCl3 and Cl2. That is given in the question paper itself. PCl5 undergoes dissociation to give rise to PCl5 undergoes dissociation to give rise to PCl3 and Cl2. If the total pressure of the system, actually the data that is given is the total pressure of the system is P and the density rho, the density is also rho, and the temperature T. If the vapor pressure, the vapor density of the mixture at equilibrium has the value of 62, the vapor density we have to make use of the principle vapor density is equal to half the molecular weight, or 2 into vapor density is equal to the molecular weight, when the temperature is 230 degrees centigrade. These are all the information that is given. So from this we will have to find out how much is that. This is the original, this is actually alpha, the degree of dissociation. Alpha is equal to, you can calculate the degree of dissociation, what is remaining will be 62 divided by 104.2 minus 62 divided by 62, this is equal to the degree of dissociation alpha, that is the amount of the substance that is undergoing the decomposition, is actually given by the equation. The original equation is given by, it is one will give alpha will decompose, one will decompose, so 1 minus alpha will be remaining, alpha will be remaining, alpha will be remaining. Making use of all this, we can calculate the degree of dissociation, making use of the usual formula to give rise to, that is equal to 0.68. That is actually the first statement that is given. A, degree of dissociation is equal to 0.68. So that is a correct statement. Then coming to the second statement, the value of P by rho, the value of P by rho is equal to, that can be given by 1 plus alpha into RT divided by M. This will give the value of P by rho, that actually works out to 0.3327 atmospheres. Actually it can be given as 0.3327 atmosphere or so many grams per liter, that can also be given. So the answer, the second statement is a value of P by rho is equal to 0.3327. That B also seems to be a correct statement. Regarding C, degree of dissociation is equal to 0.3327 is not correct. Actually the degree of dissociation is equal to 0.68, alpha is equal to 0.68, which corresponds to the value of A. Therefore C is not a correct statement. Then coming to D, the value of P by rho, again the value of P by rho is only, the value of P by rho is equal to only 0.3327 and not 0.68. Therefore D also is not correct. Therefore only A and B are the two correct statements and not the other two, namely C and D. We will have to make use of the equation, simply make use of the equation that PCl5 will give rise to, supposing 1 mole will give rise to, in the beginning 1 mole will be there 0 0, and then alpha will decompose, therefore 1 minus alpha will be remaining here, alpha will be there, making use of them, substitute, arrive at the value of the equilibrium constant, and then make use of the pressure values, then you will get the degree of dissociation, you can arrive at the value as 0.68. So that is how you get the values. A and B are correct values that are given there as given in the question paper. A is 0.68, the value of dissociation constant, and the value of P by rho is equal to 0.3327. So A and B are correct answers and C and D are not.